Okay, so when it comes to knowing right triangle trigonometry, one of the things that we want to do is that we want to talk about the trigonometric ratios of certain angles. And there are actually three types of angles that we definitely always concentrate on. They are 30-degree angles, 45-degree angles, and 60-degree angles. So we're going to address here in the next few videos how to go through the trigonometric ratios of these three specific angles. Right, so that's our topic right here. So the first one that I want to hit on covers two of the triangles. They are the 60-degree triangles right here. Well, how do you get that? I know people have gone through their own trigonometry course in high school and have memorized unit circles and tables. Do not do that. You can memorize some values, you can certainly know them, but it's much more helpful to understand why you're getting what you're getting and to use that angle. So I'm going to do it right here for my 60-degree angle by telling you that the way you remember it is to start out with a equilateral triangle. Equilateral triangles have the property that all the angles are equal, thus equilateral. And in this particular case, the internal angles must add up to 180 degrees divided three ways. That's 60 degrees. So each of these angles right here are 60-degree angles. All right, so you imagine this figure right here, and I give the lengths of the side of each of these two, right? Now imagine that we're going to take this triangle and we're going to just chop it in half, right? Because our trigonometric ratios only apply to right triangles, we want to create two right triangles out of this, so that's what we're going to do. So we chop it in half, and of course what happens is that, well, we've got a 60-degree angle now, but we've divided our angle up here in half, and so we've got this 30-degree angle up at the top. All right, so now take half of this triangle right here and just examine it. Right, here we are. So let me scroll this back up. Here we go. Okay, so we've got this right triangle now that we've formed by just chopping it in half. Look at the values that we get. First of all, the length of the side right here would have to be 1, right? If you chop the length of the side 2 in half, you're going to get two sides of length 1. As far as the third side goes, y square root of 3, well, use your Pythagorean Theorem. A squared plus b squared equals c squared. In this case, we know c squared and we know a squared, but we would not know b squared necessarily, right? So we could make our substitutions here and say, well, 1 squared plus b squared is equal to c squared. In this case, that's 2 squared. And working through the numbers, 1 plus b squared equals 4. Subtracting 1 from both sides gives me b squared is equal to 3. And there it is. B has to be the square root of 3. So now how can we use this? Well, now if anybody asks you and says, well, let's find the sine of the angle 60 degrees, you can tell them that it's the ratio of the opposite side to the hypotenuse square root of 3 over 2. What about the cosine of 60 degrees? Well, for the cosine of 60 degrees, same kind of business. We can say that's equal to the adjacent of the hypotenuse side 1/2. And then for the tangent of 60 degrees, we're going to take our opposite over adjacent side, so that's going to be square root of 3 over 1, or just simply square root of 3. Now our other three trigonometric functions are those reciprocals, so we could take our cosecant of 60 degrees to be 2 over the square root of 3 when we take the reciprocal, or if we rationalize the denominator, we would write 2 times the square root of 3 over 3. For the secant of 60 degrees, we do a similar thing, except that instead of taking 1 over 2, we take 2 over 1, or just 2. And for the cotangent of 60 degrees, we could write Square root of 3, well, 1 over that. So 1 over the square root of 3, and then we rationalize the denominator to get square root of 3 over 3. Okay, so there are our ratios, our 6 trigonometric ratios for 60 degrees. Now, you ask, well, what else could we possibly do to this thing? Well, I'll tell you what we could do. One thing that we could do, because we are math instructors and like doing this kind of thing, is that we could just simply say, all right, you're so smart, find for us the 6 trigonometric ratios of the angle pi over 3. Well, what is that pi over 3? If you don't remember, pi over 3 is the radian measure for one of these angles that we know. So let's convert it over. Let's say 180 over pi multiplied by our angle in radians gives us our angle in degrees. So we take pi, that divides out. We're left with 180 over 3. And of course, 180 when divided by 3 is equal to 60 degrees. So pi over 3 is the equivalent right here. So in fact, all of these same ratios that we were dealing with before happen here as well. 1, 2, square root of 3. And so if I asked you to find for me the sine of the angle pi over 3, well, you had better remember that that is equal to the square root of 3 over 2. Or if I asked you for the cosine of the angle pi over 3, you would tell me 1/2. And so on down the line. Okay, so you will definitely want to know all of these triangles, all of these angles, or these trigonometric ratios for the 60-degree angle, and the main part for that is remembering how they came about in the first place. So 60 degree, that's your equilateral triangle.